Good morning and welcome to this webcast on designing mould tools in SolidWorks with me, Ed Hawkins from Innova Systems. We'll switch straight over into SolidWorks now and we'll take a look at what we're going to be working on. As many of you will already know, we can design plastic parts very effectively in SolidWorks, but as a mould tool designer you probably receive all kinds of neutral file formats, some of which may require modification, or you may want to look at them and see how costly the mould tool is going to be before you sort of quote. So straight away we're going to go onto the Evaluate toolbar and use something called undercut analysis to take a look at this particular component. So using this tool we can select a plane to indicate a pull direction. We can toggle off certain faces and analyse where undercuts appear. So we can see that there's actually 3 undercut areas in this particular component. So straight away the price of our mould tool has gone up. So if we come out of the undercut analysis, one of the other useful tools we have is draft analysis. So again, working very much in the same way, we can select a plane for a pull direction, we can alter the angle that we want to look at, and we can take a look and, very easily we can see areas that may have a problem. So over here we can see that we've got some yellow faces indicating no draft, so we would need to modify this part to add that draft. Now typically what tends to be the case is you may go back to your customer and say, this area needs draft on it now, or if you can't wait that long, then what we can do is modify the geometry using some of the tools in SolidWorks. So here, for example, we want to add draft to these faces. It's an imported part, so we can't change features or add, modify features or restructure the tree or anything like that. So what we need to do is use some direct editing tools. One of those is available from the Surfaces toolbar. So if I turn that on, we've got Delete Face here. The reason we need to use the Delete Face tool is we can't apply draft to these faces at the moment because there's a fillet applied here. So what we need to do is remove that fillet. So using Delete Face, I can select the appropriate fillets to remove, which are these ones here. So we'll get rid of those just by selecting them like so. Using the delete and patch option, what the software will do is it will stitch up the boundary and make it as if that fillet was never there. So we can see there straight away that that fillet is gone. So what we now need to do is add some draft to those faces. So again, if I just come up to the top here and turn on the Mould Tools toolbar, the draft tool is available from here, so we can use that draft tool. All we need to do is select a neutral plane to indicate again the pull direction and specify a draft angle, and then we can just pick the faces that we want to draft, which are these yellow ones here, and then just accept that tool, and you'll see the colour of the draft analysis changes straight away to reflect the change we've made. Now those fillets were 0.35mm, so we really need to add those back on. So I can just add those back on with the fillet tool and select any additional edges that I require. You'll see the fillet tool is quite smart in that it picks up tangencies to give us multiple edges. So there we've added that fillet back on. So the changes we've made have been very quick. We don't need to go back to the customer and ask them to make that change. We can do it ourselves. Okay, we can come out of the draft analysis tool now and concentrate a little bit more on creating a mould tool for this component. So further down in my tree I've got a couple of folders with some profile sketches in and bits and pieces like that. So I'm just going to roll down a little bit just to enable me to use those. And we'll talk a little bit about the Mould Tools toolbar. So at the top on the right hand side we've got the main commands that we're going to be using running along the top, and it's always a good idea to work from left to right. Now you can use the automatic tools or you can do this manually. We're going to use the automatic tools to do the bits and pieces that we need to do. So firstly we're going to need to create a parting line. So the parting line tool uses draft analysis to analyse the part and figure out where the best parting line is. So if we start draft analysis, we can see it detects the parting line around a sort of useful split line in the component. Now the parting line tool is automatic, but you can manually do this as well. So you could delete all the smart selection edges here and manually pick the edges that you want to use for the parting line, which is great. It's also worth pointing out the message boxes at the top here. It tells us the parting line is complete, but the mould cannot be separated because we've got some open regions, so we need to create shutoff surfaces. So we'll do that next, but we'll accept that parting line because it looks quite good. And just up here on the view toolbar, we can turn parting lines on so they're visible as well. So our shutoff surfaces need to be here and here. Again, we've got a tool to do that, so we can start that tool and it will detect any open regions of the component to close up. There's some options in here for how we deal with creating surfaces in those areas. You'll see here that at the moment this area is set to contact, but ideally we want to maintain a tangency across that area, so we can just toggle on tangent and flip the direction there, and it will create a tangent surface across that open region. If they are, in your components, if the areas where the shutoff surfaces need to be are a little bit more complicated than what we have here, you can use standard surface tools to create those in a better way than the automatic tool may. You'll see as well, also at the top, we've got a green box saying that the system can separate it into a core and cavity now. So we'll just accept that and we'll let the system create those surfaces. Okay, so we can see those there are very good. It's worth pointing out at this stage as well that in the surface body folders, the system is doing some things in the background for us. If I just hide that solid body, we can see in a little bit more detail. So we've now got cavity surface bodies and core surface bodies folders in our tree, and the system creates surfaces that are offset by a distance of 0, so effectively copied surfaces for the top and the bottom halves of the mould. It does this based on the fact that we're using the automatic tools. Again, you can do this manually using the offset surface command on the surfaces toolbar, but the automatic tool is very good at this and a lot quicker than you having to manually select those faces. So the next thing we need to do is create a parting surface, and if we just hide the bottom section of surfaces, we can see we've got our parting line running around the outside. So if I use the automatic tool here, it's going to use that parting surface, or parting line, sorry, and attempt to create a surface from it. So we've got some options in here for size of that surface. You can also toggle on manual mode again for more complicated areas and drag the handles around, or also create different sort of sections if you need to. So if we add that parting surface on like so, you'll see it's a little bit messy, but it would do the job. But we've actually got a single surface running around the inside of there that we could use for our parting surface. So I'm going to delete that feature and we'll manually create our own surface body for that. Now you see, because I've used the automatic tool, we've also got a folder for parting surfaces in there as well. We'll look at what that does in a moment. But if you do want to reuse surfaces from your component, it's quite easy to do that. On the surfaces toolbar we have a tool called untrim surface. So if I start the untrim surface tool, what that will do is it almost takes a copy of the surface that we're working on and allows us to extend it by a given percentage, and we can specify whether we want all edges or certain edges. We can also choose to merge it with the original or not. In this instance I actually want to create a copy of it, so I'm going to say don't merge with the original. If I click the tick there, then we get our additional surface. Now at the moment that goes right through the component itself, so we need to do a little bit of trimming. So using trim surface here, I can actually use the parting line to trim the surface and then select which bits that I want to keep. So here I want to keep this item. So you can see all I need to do is click and then that's selected, and if I right click here, then it's going to remove the inside bit for me. So now I have a surface that's stopped at that parting line. but we may want to just trim that surface back a little bit closer to the mould just to tighten that into the insert that we're going to be using. So I've got a profile here that I want to use to trim. It's just a sketch profile which has been created earlier. So again, using trim surface, I can tell the system that I want to keep the outside bit, or the inside bit, sorry. Let's just reverse that, like so. So now that we've created our manual parting surface, what we need to do is actually position that into the parting surface bodies folder here, so the system knows that that's what it is. So all we need to do is just drag and drop it into that folder. If we just have a look on the Mould Tools toolbar here, if you are using the more manual methods to create mould tools, you can actually just insert the mould tool folders yourself using this button, and that will put those three in there so you can categorize the bits individually. The next stage for us really is to actually create the insert and split it into the two halves, and we can do that using the tooling split tool. So if I start that tool, it's going to ask for a sketch to use. So if I go into my profiles folder, I've got an in the profiles section here. So we can use that to create our two halves of the mould, and you'll see here that we're going upwards and downwards by a set distance. It's detected our core surfaces, our cavity surfaces and our parting surfaces automatically. Now if I try and use this tool now, it's going to give me an error because the parting surface isn't wider than the bounding sketch. So we can use an option here to interlock the surface, and with that interlock surface we can also specify a draft angle which will allow the two sections of the mould to be separated. So if I click the green tick there, then we'll end up with our two halves of the mould, and we'll take a look at that in a little bit more detail. We don't need to see the parting line anymore, so we can turn that off, and we'll just make sure that our surface bodies are also turned off as well, just so we can see in a little bit more detail. The component itself is also invisible, so if I just hide this top section, we can take a look at the bottom section of the mould, and we can see that that's done a very good job of that. Now moving on from this, we sort of looked at the start of the areas that required undercuts, and we've got an area here and then the same on the opposing side, and we can use the core tool within the Mould Tools folder to actually create those for us. So if we just take a look a little bit further down in my tree, I've got a sketch here called Side Core Profile which has been started, so I'm just going to edit that sketch and take a look at it. We'll put this into a hidden detail so we can see. I actually need this sketch to come up to these bits that require reliefing here, so I'm actually just going to add a collinear relationship to that line just to position that for me, like so, and now it's contacted with that area. So we can then go onto the Mould Tools folder and use that core tool to generate those cores for us. You'll see it picks up the sketch and the plane for us for the direction. All we need to do is select a body that we want to cut out of and give it a couple of distance values here. So we're just going to add on 10 mil, click the green tick, and what we'll see when we go back into our shaded mode is that it's actually created a separate body within there for us. And if we just take a look at that in a little bit more detail, you'll see that area there that needs to be created by those side cores. Now these side cores won't come out easily at the moment because there's no draft applied, so what I'm going to do is I'm just going to move this item out of the way temporarily, just so we can apply draft a little bit easier, and then we'll apply draft to each of these inserts here. So using the draft tool, we just need to pick a face and then select the faces we want to draft and the angle we want to draft by, and also the direction. So we'll do that internally there. Enter or repeat your last command, which just makes life a bit easier if you're doing this over and over again. So we've done the inside as well. Let's come over to the opposing side and grab those two faces, and we'll do one final bit on the inside here as well. Okay, so we'll just suppress that move copy body command, and we'll make sure that we've got our draft going in the right directions, which we have. We haven't got any intersecting bodies. So now that sort of core bit is done, we can concentrate on creating a sort of lifter section for this area at the back here as well. So we're going to look at creating the core for the lifter, or a lifter at the back here for this section. So we'll need to create a sketch for that. So if I just put myself into a side or the correct view here, and we'll just go into hidden lines again, we can create a sketch for this lifter profile very quickly. We're going to copy some geometry so it remains parametric, and then just add a bit more detail to it. So I'm just going to draw a line down like so, and we'll continue that to the bottom, and we'll just finish that off like that. Just make sure those two are parallel, and we'll just pin on a couple of dimensions here as well. Okay, so now we've got our profile defined. We don't need to worry about the height of this because we're only going to be cutting out of this body. So now again we can go to our mould tools folder and use the core tool. Again, specify some distances here. Again, we just need to specify the body we're going to cut out of, and then we can create that lifter profile. So all that's really doing there is just allowing us to lift that section up to pop the component out of the mould once it's finished, really. Okay, so we're getting on quite nicely now. On the subject of actually getting the component out of the tool, what we would also need to do is have some ejector pin locations. So again, here I've got a sketch for those. We need to make some holes for them. All we've got is a circular hole there, which I'm just going to cut out of that main body. So if we do up to next and specify this body only, we can just click the green tick and create a hole in the mould. Now typically you'll need quite a few of these, and using some nice tools in SolidWorks we can generate these very quickly. So we have a sketch here which has a load of points in indicating those locations, and I can use something called a sketch driven pattern here, which will use each of those points and then place the feature that I want to pattern at each of those points. So you'll see here I can just select those very quickly, and we've now created all the ejector pin locations. Okay, so that's us pretty much done on the base of the mould. If we just show the top section again, just so we can see it, what we may need to do is figure out how we're going to put the plastic into this component. And normally these are done with a number of features to create the sort of gate locations and sprues and things like that. What you can do is, if you're using these over and over again, is you can actually save them away as library features. So SolidWorks is very good at taking combinations of features and allowing you to reuse those in other designs. So within a folder in my design library here, I've got a sprue run a gate feature, and all I need to do is just drag and drop it onto the component and then position it with a couple of references. So we'll do that now, and then we can see that feature goes in no problem at all. So design reuse is a very sort of important part of SolidWorks, and we can do that nicely with the design library features. Okay, so once you've got your mould tool complete, we may want to put this into an actual mould assembly. And one of the other nice things we have in SolidWorks, at the moment we've been working on a single part file, but you know, we may want this as an assembly of components that we can sort of separate the two halves out and things like that. So what we can do, even though we are working on a single part, is we can actually use the save bodies command here, and what that will do is it will save each of the bodies out into separate part files. So all we need to do is assign some names to those. We can create an assembly from here as well directly. So if I just create an assembly, just give it a name and save it, we can just click the green tick, and what the software will do is it will output each of those bodies into a separate part file and also construct an assembly for us as well. And we'll take a look at the assembly that it's created. So now we have an assembly of all those components. You know, we can create things like exploded views very quickly just to show how this goes apart if we need to. So we might want to indicate to somebody which order these bits and pieces come apart, or how it works, which we can do like so. And with those exploded views, you do get an animated view as well for free. So, you know, just quite a nice way to do that. Again, as I say, we might actually want to use this in a main assembly. So if we take a look at a mould based assembly, this has been constructed from Hasco bits and pieces from 3D Content Central, which is a free website where you can download these bits and pieces from. So if you do want to show things into mould tools like this, you can do that. It's not a problem at all. If you do need any of these bits and pieces, if you go to 3D Content Central, you can grab them from there, or alternatively, if you just give us a call, we can supply those files for you as well. So I could actually insert that into our mould here. So if we just section through that, and just so you can see, we've actually now got our mould in our mould tool folder. Okay, so that sort of brings us to the end of this demonstration on how we can use SolidWorks for mould tools, but there is one other thing that I want to show you as well which I'll talk about now. So I'm just going to close a few bits and pieces down, and if we just revert back to our original file here, what I do want to talk about is a new product that SolidWorks have released called SolidWorks Plastics. So, you know, not only can we create mould tools in SolidWorks, but now we have the ability to analyse whether or not they will fill certain other aspects of plastic components as well. So this is an add-in from SolidWorks, so we need to turn this on. If you do require any more information about this, then please get in contact with us. It is a very new product, so you know, we have got pricing for this and bits and pieces, and the training will come online very soon. But as I say, if you want to know a little bit more about what it does and how it does it, then please get in contact. So you'll see it appears as a tab on our toolbar, and over on the left hand side it has a property manager very similar to simulation. So what we can do with this, it works on a mesh system, again very much like SolidWorks simulation. So we need to create a mesh, and there are automatic and manual settings for those. I've already got my mesh created here, so the next thing I need to do is select a material. And another great thing about SolidWorks Plastics is the size of the database of plastics that it has. As you can see, we've got a large amount of different types of plastics from different suppliers. It carries all the properties you would need within those materials to analyse the mould flow and other aspects of plastic design. So we'll stick with the material we've got there. The next thing we need to do is choose a machine. So I've just selected a default machine, but you'll see there's a large number of manufacturers within here and machine types which you can select from, with numerous different settings within them. We'll stick with the large option there. Gates, we can choose our location of gates. If I just delete this one, and we'll re-add one in. So all we need to do from a gate perspective is select either an edge or a face, and then specify how large the gate is, the number of gates, the type of injection system, that kind of thing, and we can add that in very easily like so, and then we'll run that simulation. So now the simulation's finished, we can take a look at some of the results. So one of the first ones we get is a fill time animation, which will tell us how long it's actually going to take to fill this component. So if we let this run till the end, we'll see it takes just under 1 second to fill it. You'll see on the left hand side we've also got some other options as well, one of which is a sync mark analyzer. So we can take a look at the opposing side of the component here, where the